you're dealing with each one of the terms having the same ratio. By that I mean you're multiplying or dividing by the same thing each time between all the terms. Okay? So it's going to look just a little bit different. It'll state that it's geometric. When it's geometric, that means they have a common ratio. So instead of having a D value, we are going to have R. It always sounds funny. Yeah. So we have an R value now. Let me ask you this. What is a ratio? Geometric mean. Geometric means awful.
I forgot what the formula thing was for. So that's when we did geometric mean.
What is a ratio, guys? What is a ratio? Louder. You're on the right track. I hear you.
Wait, what?
Yeah.
I think I'm right, but I said comparing two.
Ratio doesn't mean the same amount.
By what? You're right. Comparing two numbers by.
Wait, is that the thing where you do like x over the number times? No, actually.
You're thinking of geometric mean. That's what you guys are kind of wondering about as well.
Okay.
Oh, just a plain old ratio is just a comparison of two numbers by division. Okay? So what happens here is that you wind up with sequences, and in order to tell if something is geometric, that means each consecutive term has the same ratio. Consecutive means what?
In a row.
In a row, one after another. Now, how we check to see if something has or is geometric to check to see if its ratios are the same is we do the following. I take the second term divided by the first. Does that equal the third term divided by the second? Does that equal the fourth term divided by the third? Does that equal the fifth term divided by the fourth? Do all those have the same ratio?
No.
No. So is that geometric? No.
Yes.
Okay. Now the other one, I do the same thing. 27 over 81. Does that equal 9 over 27? Does that equal 3 over 9? Does that equal 1 over 3?
Yeah.
It does. Do you guys know how to check simplifying fractions in the in the TI-84s?
Isn't it just you type in like a fraction and you hit equals and it'll like simplify for you?
There's actually an easier way of doing it. If you go to your calculator, oops, let me move this over some. If you go to your calculator, what I want you to do, clear all this junk out, is I want you to type in alpha y equals. And that's how you get your fraction bar. Everybody see that? Once you get your fraction bar, you type it in like you guys used to last year with your multi-views. 27 over 81, and hit enter. Dun dun dun.
Like what is that?
Oh, I thought you were going a different route.
Oh, okay.
That's all it is, guys. The calculator will simplify it for you right away. Just by using the fraction bar on there, it automatically does the simplifying for you.
So we always start, so the second number always goes on top of that?
Oh, why is that? Why the second number?
Because if you start with the first number, where do you go?
81 divided by 27 is 3.
Is that the same thing as multiplying by 1/3?
Yes.
By doing it this way, by taking second number first, I'm alleviating the mistake of saying I'm dividing by 3, then all of a sudden, if I write it this way, I'm going to get a fraction. Okay, that's just the only way, that's the reason why I do it that way. All right? Because a lot of times you guys will forget that you're dividing and just accidentally write it by multiply by 3, and then your stuff gets off. All right? So in this case, would I say that that sequence is geometric?
Yes.
Okay, so let's take it to the next step. Let's write the equation for it. I said so. It's not a lounge. The geometric nth rule for a sequence has this very, very basic formula. The nth term again, just like we were talking about yesterday. Your nth term for a geometric sequence is your first term times that common ratio to the n minus 1. Notice we're going to be working a little bit with exponents today. Okay, so some of the old-fashioned exponent works that you might have done a few years ago. You got to knock the cobwebs out of your brain to remember them. So this was the sequence we just talked about, 81, 27, 9, 3, 1. We know that the common ratio in that sequence was what? 1/3. It was 1/3. The common ratio here is 1/3. What's my first term? Okay. Do I have enough information now to write out the rule of the nth term? Yeah. All we do is substitute in. I know that the nth term is going to be my first term times my rate to the n minus 1. That's it. Yes?
Why is it 1/3 instead of 3?
Because you're dividing by 3. You're multiplying by 1/3. You're not multiplying by a third. Not multiplying, because if you're multiplying by 3, you get 243 for the next one. Then you would get 927. I think I'm wrong. Okay.
Can you scroll up?
Okay. All we have to be able to do here is figure out the common ratio in the first term. You do not simplify anything here. Okay? You just leave it just like that. All right? Let's try another one. In this case here, I'd like you to write the rule for the nth term. My sequence, -8, -12, -18, -27. It is geometric. Once it tells you that it is geometric, the first thing I'm going to do is find my rate. My rate, I take the second term, I divide it by the first. Yep, what do you get?
1.5.
Ah, but I want a fraction. Very good. I'm sure you just did 12 divided by 8, right? Did you know how to convert that back to a fraction in the calculator? Math enter. Just making sure. So there's my rate, 3/2. What's my first term? -8. So we have the nth term, first term, r, n minus 1, fill in the blanks. -8 times 3/2 to the n minus 1. What's the next thing it's going to ask you to do? Find the 8th term. Find the 8th term. So if I'm going to find the 8th term, what is my value of n?
8.
Good. Which means we have to remember how to use fraction buttons as well as exponent buttons in our calculator. Move this over so let's pull this up. Calculator-wise, -8. You guys know there's a difference between the negative button and the subtraction button, correct? Okay. -8. Now I'm going to put in parentheses. 3/2. Could I type 1.5?
Yes.
Just because it's quicker sometimes.
That's going to be lazy.
I am going to be lazy right now. It's like almost noon on a Friday. We can be a little bit lazy.
That's not bad.
You know,
I'll get over it.
1/7 of your life, roughly, will be spent on a Friday. So if you're lazy every Friday, you're lazy. That's a day.
And then
52 seconds out of a year.
I'll get over it.
just imagine how much farther you could be in life if you weren't lazy on Friday.
Bruh, come on, man. I don't want to hear.
Seriously. All right. Now, at this point, what button do we have to press to raise to an exponent? Caret button. I'm out of carrots in my house. It's driving me crazy. Caret button.
You have some.
Now what do I type?
You can have mine on.
7. Do I have to write 8 minus 1?
No.
Do you think we could probably do that in our heads?
No.
I know it's tough. You're wearing sandals, so if you have to go like 11 minus 1, you can use your toe and count for that if you had to. Now what do I press?
Input, enter.
I tried to, it didn't work. If it asks you for a fraction, you just hit math, enter, and it should give you a fraction.
If you broke it, you didn't pay for it.
I didn't break it. You didn't see it now.
I like this older though. No, she wrote out a book on dry erase marker.
Who did that?
She wrote on her smartboard with a dry erase marker.
People do that every once in a while. I just say.
that?
I've heard that story, yeah. So, as you guys can see, this is a very easy process to work with, especially when you're given the sequence. Well, it's not always fluffy bunnies and cupcakes. Sometimes you're given a specific term within the sequence. Very similar to what we did the other day, right? So, in this case, we have the geometric sequence. The third term is 5. Don't worry about this graphing thing here. We will not be graphing these at all, okay? It says that the third term in the geometric sequence is 5, and the common ratio is 2. I want to write out the rule for the nth term. Well, if the third term is 5, what's my value of n? Yep. That gives me a rate of 2. Do I have enough information now to solve for my first term? Yeah. Substitute in. 5 equals first term times 2 to the n minus 1, 3 minus 1. What's 2 minus 1? I know it's tough. Oh, my gosh.
My bad.
3 minus 1.
2. 1 9.
What's 2 squared?
2.
4.
How do I get a sub 1 by itself?
Divided by 4.
Divided by 4.
Yep.
So your first term is 5/4. Oh no! What do I do now to finish my problem?
Oh no.
Are you doing electrical work?
What does that mean?
Does that mean she has her phone?
So your nth rule,
Oh.
first term, rates. Okay? Extremely straightforward when you're setting up the nth rule for geometric problems. There's not, you don't really have that mistake that happens when you're multiplying by negatives and combining like terms like you do with arithmetic stuff. It's a little bit more straightforward. Okay? So you want to see the bad stuff then?
Bad stuff.
Wait. Wait. Yes, ma'am. Right here? It's the rate. It gave you the common rate at the beginning of the problem. It said the common ratio was 2. Don't bang on your chair.
See, I can't help
Get
it.
back on your knees.
I can't help it.
This is why we have to know how.
Okay? So, why don't you try one real quick? Oh, wait, let's do this one. Now we're given 2 terms. Now we're going to find the nth rule when you're given 2 terms. Yesterday or the day before, when we did arithmetic, given 2 terms, what did I tell you guys to do twice? Write the equation. So I'm going to write out the geometric nth rule twice. There a sub n, first term, r, n minus 1, a sub n, r, oops, first term, r, n minus 1. And what I'm going to do here is I'm going to write out as much as I can for both of the individual n values that I'm given. In the first example, I'm given the second term is 45. So I write that down. Second term is 45. Therefore, what is n equal to in that term? It's 2. Everybody okay with that? N is equal to 2. Do I know what my rate is?
No.
Do I know what my first term is? So I'm just going to substitute in what I know now. I know that the the 45 is first term rate to the 2 minus 1. What's 2 minus 1? 1. 45 is first term times the rate. I can't go any further than that, can I? Nope. So I'm going to do the same basic thing with the second term that they gave me. Within the second term, we know that the fifth term is negative 12, 15. Therefore, what is n? 5. Now I'm going to again substitute in what I know. I know that the fifth term is 12, 15. I don't know what the first term is. I don't know the rate, but I know that it's n minus 1. So you get what? 4. So now I have two equations with two variables, but I cannot combine them using linear combination because they're multiplying. Well, there is a way to do this. Substitution. Okay? We're going to treat the equation on the left, the 45 equals first term times the rate, as what they call a literal equation. You guys ever heard of that before? What is it? Do you agree on that? Distance equals rate times time.
Yes.
How do you solve for rate?
Divide
Okay, so distance divided by time is your rate.
Yeah.
Okay. How would I solve that equation for time?
times by t.
How would I solve this one for time? What you're doing there is you're working with what's called a literal equation. You're just solving for the independent parts within it. In this 45, in this equation here, what I want you to notice, see how the first term is isolated in both of them without different exponents, without any coefficients and all that? What I want to do is I want to get the first term by itself on the equation on the left. How do I get it by itself? Divide by? I got to divide because this is multiplying, okay? So if I divide both sides here by the rate, do I say that 45 divided by the rate is the first term?
Yes.
Are we okay with that?
Yes.
See how it matches up with distance equals rate times time? Same basic principle. Now, I can take this and substitute there. Now I have one variable. Okay? Here's where it gets messy though. Let me move this up a little bit. We're okay, we have negative 12. 15 is now 45 divided by r times r to the 4th. Do you remember what you do with your exponents in this case?
Not at all.
No. Let me ask you this real quick. Yeah. You're on the right track. Let me ask you this real fast. I'll come back to this. What does this mean? Okay. And this is divided by r, correct? What drops? How many r's are you left with? So,
Why'd you divide by R?
what's r divided by r? 1. What I'm doing is I'm taking out a set of ones. Okay. Exponent rules tell you that, for lack of better terms, what's bigger, 8 or 3? So who wins the battle of war? What's 8 minus 3?
5.
Okay. In this one, if it's r to the 3rd divided by r to the 12th, who wins the battle? So what's 12 minus 3? Now, in this case, since it stays in the denominator, r stays down here, and a 1 goes up top. That's using some of your exponent rules. That's something you probably don't remember. Okay. It's a very simple thing. You'll probably be more likely using this one as opposed to this one yet, but eventually we'll go back to that. Okay? Just so you remind yourselves of what it looks like. When you're working with exponents, it's a matter of who's winning. And in these style problems, the numerator is going to win. So as I go back here, we left off with r divided by r, excuse me, r to the 4th divided by r. What do I get? R cubed, r to the 3rd. So I'm left with negative 1215 is 45 r cubed. Now it's nothing more than a two-step equation. What do you do first? Good. Divide both sides by 45. You get negative 27. If you had to undo squaring, you guys would take the square root. If you have to undo cubing, you have to take the cube root. If you have to undo the 4th power, you'd have to take the, if you have to undo the 8th power, you'd have to take the, which means you have to remember where the button is on your calculator. Go back to the calculator, hit the button that says math. If you need to find the cube roots, the cube root button is the 4th button. And it pops up with the cube root, and you just have to type in negative 27. You should get negative 3. So that means my rate is negative 3. Now, the other button on here I want to show you, if you look at number 5, number 5 says x root. That means you can take any nth root. You can change the indice. You can change the index. If you want to take the 7th root, you can type in 7 root something. The 5th root, 4th root, whatever it may be. Instead of being the cube root, in that math option one, it's the one that says x root. Does that make sense? That's how you change that one around. So now I know that the rate is negative 3. I'm not done. I still don't know what my first term is. What do I do?
Put it in.
Just go overboard.
I don't
No,
know.
not plug. She didn't say plug. She said plug.
The word.
Put it in? What are you, like, trying to score a goal? Put it in the net!
Substitute.
Thank you.
Oh, yeah, that's what we call it.
Sorry, you weren't loud enough. I go right, because it's the easiest place to put it. What's 45 divided by negative 3? Negative 15. So my first term is negative 15. So my nth rule is first term times the rate to the n minus 1. It's not a very complicated scenario to do. It takes a little bit longer, plus because there's a couple of new buttons and things you have to set up in the calculator to make it work. All right? Yes, sir?
So when you did negative 1215 equals 45 over r times r to the 4th,
Uh-huh.
did you cancel? Okay.
Because this is r to the 1st power. So who wins that battle of war? So it's just 4 minus 1, I get that. And it goes back to the idea of what you're doing is here is you're taking out a grouping of 1. Okay. So do this one. Same basic idea. Write out the nth rule, please. Hold on.
Yeah. I got this.
I think that's right.
Yeah.
If I'm not mistaken. Remember, the most generic way to set these things up, always write out your rule. Substitute in.
That's why that might be wrong. I don't know negative.
Wait, is it 231?
I got 230.
No, I got 256.
256. Because you divide by -4.
Oh yeah, it's negative. Sorry. Yeah. So then when you take the 4 through to 256, you get 4, correct? So your rate is 4. So your first term is -1. This is easy to write off the rule. What I want you to do tonight is on 11.3. We didn't get a chance to finish up the second part of this.
That's all right.
Once you write this out, I'll be right there, okay? It's on 11.3. It's on page, let me steal yours real quick, please. 670. We'll just do these to start with. I'm just going to give you a grouping of odds. We'll worry about writing out the series of it on Monday. Okay?
It states that's numerical.
Yes, ma'am. Guys, I finally got my flex passes. I'm going to go back on that little cabinet thing. Please make sure you sign them out.
Wait, am I okay just using my agenda for tonight?
Yeah, that's fine.